This is question number 10 of chapter number 3, which you can find on page number 46 of your book. The question says that a 60 Hz 635 megavolt ampere 24 kilovolt synchronous generator is supplying its rated load current and at rated voltage and a power factor of 0.9 lagging. Ignoring the resistance and assuming the reactance is 1.724 ohms per phase, find the induced EMF of the generator. So the question is basically asking you to find the induced EMF. For that, what will we find? We will find the phase current, the magnitude of the phase current first. How do we find it? Just divide it with the apparent. Just divide the apparent power, which is given to you in the question, with the line voltage and square root of 3. So it is 635 megavolt ampere from the question, divided by 24 kilovolt, which is also given to you in the question, and also divided by square root of 3. You get the answer of current to be 15,276 amperes. Now the phase voltage can be calculated by simply dividing the line to line voltage given to you in the question, which is 24 kilovolt, by square root of 3. So you get the phase voltage to be 13,856 volts. What about the angle theta? You just find it by taking the cosine inverse of the power factor given to you in the question. So the angle comes out to be 25.84 degrees. Now the phase voltage can be written as 13,856 with an angle of 0. So we are taking the voltage of phase A to be reference. So in this way, the phase A current will be 15,276 with an angle of minus 25.84 degrees. This is theta with a negative sign. Why is this a negative sign? Because it was given to you in the question that it is lagging. After finding this, you will just simply put all these values in this equation. The simple equation of a generator, VA equals to EA minus X times reactance times the J times the reactance times the phase current. There is no resistance part over here because the question already says that the resistance, we are ignoring the resistance. So the resistance value is 0 here. So R multiplied by IA is ignored over here. So you're simply left with this equation. Just put the values of whatever we know up till now and rearrange and solve it for EA, and you will get the final answer of the induced EMF to be 34,693 with an angle of 43.1 degrees. Because this is actually a phasor equation, you can solve it in your scientific calculators by simply putting it directly as phasor values, or you can just convert them into rectangular coordinates and then solve it and then convert it back to phasor. It's up to you, whichever way you choose. The final answer should be this one.